Okay, now second exercise of topic 7. In this case, we need to again draw the time evolution of signals. Q are these signals here. SP means shift or load in parallel. D0, D1 and D2, that are the outputs of this shift register when the inputs take the value as indicated on the chronogram. Okay, so let's take a closer look at the circuit. Okay, the circuit, it's two synchronous blocks. It's a counter that can count upward and downwards. Look at the M1 signal that can count or load in parallel the inputs of the bistable, and also have a reset signal, okay, and of course a clock that make it synchronous. The SP signal, the shift or load in parallel signal, is connected to the propagation counter. That means when the counter has finished, it has reached the last number, it propagates a pulse, so the next counter can count, or here we're going to use it to load this value into the shift register. The shift register takes the inputs for parallel loading from the counter, if not, is shifting the signals, right, that it has on its flip-flops, right, and also has a reset signal, and it takes the same clock like the counter. So both systems will evolve simultaneously, synchronously, right? So that's what we need to take into account. For the input signals, we have a clock. I have it right draw, just I can play. We have a clock, right? The clock is the same for both the counter and the shift register. We have a PI signal, that is poner inicialmente in Spanish, so that will be the reset signal, so it's active at the beginning. Then there's a signal that makes counting or loading into parallel for the counter. Also there's a signal to say count ascending when it's 0 or descending when it's 1. And there are some empty boxes to put the output Q, so we have to put the numbers here of the count. The SP signal, because it's generated by the counter, so we need to draw this signal too. And D0, D1, and D2 and D3. Okay, so let's take a look on what edges, in this case, are both systems work with the rising edges, okay, simultaneously of the clock, and what the signals that are on the inputs will do. So the first thing I can see, because the first signal that's going to change is a rising edge of the clock, but as the reset is active, the signal won't take effect. I mean, this rising edge here, I think that you can see the cursor on my screen, it's recorded, so here, so this first rising edge won't take effect because we are acting on the reset of both the counter and the shift register, right? So the next signal that's gonna do something is the reset, and it will stop working here. So from this we will evolve. Then this load in parallel or count will take different value here. So first we are loading an initial value on the counter, and then we can count once we get released from here. And there's also this other rising edge here on the AD signal that changes the behavior of the counter. First we are counting ascending because it's 0, and then we are going to count downwards because it's 1. Okay, that's it. That's what I have. So I'm going to put the lines, yeah, the specific line of where should we take into account the previous state of signals to make the counter and the shift register evolve. So this is for the reset, the count or loading to parallel, and the ascending descending signals. And now we have to put also the rising edge of the clock. So we take a look at what's going on. So those are all the lines that are the important instant where we should take care of them and see what's going on in our counter and our shift register. Okay, so the first thing we are going to say is that this first box should be 0, right? Because we have the reset signal activated, so we put it to 0 no matter what. Here is the reset acting, so the first box must have a 0. And then comes a rising, a rising edge. But what happens with the rising edge? That we have this counting loading signal set to 1. So this rising edge will make the value that we have at the inputs of the counter to get into the Q state. So we're going to change from 0 to, this is Q3 is 1, Q2 is 0, Q1 is 1, and Q0 is 0. So we have the 8 and the 2. This is going to be a 10 decimal or a x decimal. So, and the SP signal will be 0 because we didn't reach the highest number in the counter. So also all the D beastables will be 0, right? And now we have the A. Okay, so what's next? Next is that now we are counting ascending, right? So the next thing that's gonna happen is on the rising edge. So till then we have to propagate or establish the value of signal SP, D0, D1, D2, and D3. And these signals will be remaining in 0. There's nothing gonna change. So they are going to stay in 0. There's nothing to propagate other than zeros, right? And the SP, it's not active, so nothing is gonna, we are going to propagate this 0 here to here, this 0, the 0 for D1 to D2, the 0 from D2 to D3, and the 0 from D3 will be lost, okay? So now, on the next rising edge, things are gonna change simultaneously in the counter and in the shift register. So let's start with the counter. The counter is counting ascending. So from A we are going to move to B. Okay? And that's it. B will be present at the outputs of Q. Okay? But the SP signal, as this is B, it's not F that is the maximum value that we are going to count. SP will remain in 0. Okay? And as SP remains in 0, we are shifting our register. For our register, here the input of this Q0, now that we have the A number here, the A number is here too. So we are going to propagate this 0 that is at Q0 output will be here. So from the beastable D0 will be propagating the 0 from the Q0, and D1 will be D0, that is also 0. D2 will be 0, that is because D1 is 0, and D3 will be 0, and the value in D3 will be lost. So now we are with a very flat system. This is odd, but it's okay. It's what's going on. So the next rising edge will increase the counter, and the counter that now is B will be C. And of course, as we don't have the maximum, I just put just the SP signal, and the SP signal will be 0 because we didn't reach the maximum. And now what's gonna happen? Okay, now here in Q0, Q1, Q2, and Q3 we have B, and B the bistable Q0 has the number 1 because B is 11. So we have number 1 prior to rising this. So D0 will become 1. And D1, as D0 is 0, will be propagated from D1. D2 will propagate in from D1. And D3 will propagate in from D2. So this is the outputs of the shift register. See, now we have a 1 in D0 and we have the zeros that propagates at the other outputs. So again, we have a rising edge right here and the control signals have no changes. So from C we move to D at the outputs of the register. And this is not also the maximum value we can have, so we don't have this. Yeah, so our SP signal remains in 0. And now when the signal arrives here, Q0, it's from Z, and C, the first bit is 0. So this 0 will become 0. And this 1 that is in this 0 will propagate to D1, and the 0 that is in D1 will propagate to D2, and the 0 that is in D2 will propagate to D3, and the 0 that is here will be lost. Okay, so this is counting and evolving at the same time. Remember that we are taking the signals that they are just right before the edge rises. Okay, so now from D, the signals, control signals, are the same, and when the edge rises from D we move to E, and E is not the maximum value, so nothing changes. Yeah, and now what happens with D0? D0 will take the Q0 bit from D, and the Q0 bit from D is 13. This is 10, 11, 12, 13, so it's odd, so it's set to 1. So D0 will evolve to 1. D1 will evolve to 0, and D2 will evolve to 1, and D3 will evolve to 0. So this is what's on our system. See that the ripple from D0 is here. If you see the cursor moving, you can see D0, D1, and D2 propagating the 1. Then we propagating the 0, and the 0 propagating from the previous numbers. So we are shifting this way. Yeah, we are shifting this way in your image. Okay, so with the next rising edge we are still counting ascending. Okay, so we are going to F, and in between that we are going and remaining F, the signal here will change from ascending to descending. Yeah, but we are going to F, and as we are going to F, the SP signal we also will go to 1, because we are reach the end, we reach the maximum value of what we can count with this counter. Yeah, so well, two changes in the output of the counter. We will be going to F, and then our count equal to 15 will be 1. Yeah, so SP signal will be 1. But we have to take a look at what's happened and how are the signal before the edge arrive for the shift register, not what's going on after, before the edge arrives. Okay, so for this D0 we are going to take E, and E is 14, so the Q0 bits will be 0, so our D0 signal will go to 0. What's in D0 will propagate to D1, what's in D1 will propagate to D2, and what's in D2 will propagate to D3. That means that we are moving again, we are moving, right? We are moving, let me see my hands in the camera, we are moving, this way, this other way. Okay, we are moving this other way on the shift register. It's complicated because it's a mirror. Okay, it's funny. Okay, so what will happen next with the rising edge? Now our control signal for the counter is set to 1. So that means that D, AD, it's set to 1. So we are going to count decreasing. So instead of going to 0, we are going to E. And our SP signal will be go to 0 because we are no longer in F or in 15. Yeah. So I make it smaller, and now we can draw the signals. We are going to the output Q now hold the number E hexadecimal, right? The number 14 in decimal, and SP signal is 0. What will happen with signal D0? Well, look, now that SP was 1, we are not going to shift. We are going to put the values of Q into the shift register. And that means that the Q was F. The 4 bits of F are set to 1. So we are going to put 1, 1, 1 in D0, D1, D2, and D3. This is an odd change because the 4 bits will become 1. Yeah. So during this transition that is right in the middle of the chronogram, we start counting, but in the opposite directions. We are counting decreasingly, yeah, and we are charging in parallel the shift register. That's why the 4 bits have become 1, because of the F that was prior to the arrival of the shift, the rising edge of the register. So when the next rising edge arrives, our counter decreases the value of the flip-flops, so we get a D. And of course the SP signals continues to be 0 because we are no longer in F. And now we are shifting Q0 as the input of D0. But what happens in E? E is 14, so our Q0 bits will be 0. So D0 will be 0, but the 1 in D0 will propagate to D1, the 1 in D1 will propagate in D2, the 1 in D2 will propagate to D3, and the 1 in D3 will propagate, well, will be lost. So this is what we get, okay? So now this is our circumstances. Until what? The next rising edge arrives. In this case, we are going from D to E. I have to make it smaller, the circuit, and cut it off. So, yeah, we resize, and now what do we get? We get C, and the SP signal is 0 because Q, the outputs of the counters are not F. And now, as we propagate D, and D is 13, so 13 is odd, so the Q0 bit will be 1, and that's what happened in D0. And D0 that was 0 was propagated to D1, and D1 that was 1 was propagated to D2, and D2 that was 1 was also propagated to D3. When the next rising edge, we are going to B, and the SP signal is 0, right? And what happens? So C, it's 12. So the Q0, as is even, the Q0 bit will be 0. So D0 will be 0. And now as the previous value of D0 is 1, we will propagate this 1. The previous value of D1 is 0, so we propagate to D2. The previous value of D2 is 1, so we propagate to D3. Now I will move this small circuit I keep for reference to the other part of the chronogram that is flat and no matter, right? And the next pulse makes a B output become A. That's number 10. So the same thing happens. Now B, it's odd, so D will become 1, and we will propagate the signals. The next evolution will make number 9. Yeah, it's the same in decimal and hexadecimal. So, but we are shifting the Q0 bit from the counter into the register at the input D0, and the previous value is A, that is 10, that it's odd, and so it's 0, so it goes to 0, right? And it keeps doing this. So it's the same pattern every time. So we have to look what's after and put it before. Okay. So for completeness, I will remove the circuit and put the boxes and put the values of what's in D0 and D3 at the bottom. And this is the complete chronogram for the second exercises for the topic 7. Thanks for watching. Bye bye.